This is Greg Orloff with IoT World, and I'm here with George Gray, the CEO of Foundries.io. Welcome, George.
Welcome. Thanks for having me, Greg.
Thank you for joining us today. So I know Foundries is an organization, and you're working in the Linux area and possibly as well the cybersecurity aspects for IoT devices. So tell us a little bit, maybe to kick off the conversation, George, what makes cybersecurity a bit more challenging from a Linux perspective?
Yeah, when you think of Linux devices, they tend to be more capable and have more functionality than a sensor connected to a cellular connection, for example. So there's a lot more complexity. As a result, there are more attack surfaces from a security point of view. But the benefit of using Linux is you have access to this huge ecosystem of software and applications and services. And then in order to create that security, you need to secure the devices all the way down to the root of trust, and that can be very complex in some of these big SoCs, system on chips.
So maybe peel that back a little bit for us. And so if you've got a secure connection, TLS or HTTPS, doesn't that make your IoT device or your edge product secure?
No, because your IoT or edge device can be running software that you didn't intend. So, for example, somebody could have hacked your device, installed some software, running an application. They're just making secure connections. So they will request a connection to a website, and it will be done over HTTPS. But you don't trust, you can't necessarily trust that the device is running the operating system or the software that you expect, or doesn't have a virus of some kind. So a secure connection doesn't make your IoT or edge device secure. To properly secure an IoT or edge device, you actually have to make sure that it is running the software that you shipped with it, and as the manufacturer. And that requires things like secure boot. It requires you to certify as you boot the operating system that the operating system you're running is the one you intended. And then you have the challenge of updates, because updates themselves, if you think about when there's a patch to fix or a CVE, a critical vulnerability that you need to address, you need to update potentially the operating system, potentially the firmware, potentially your applications.
Right.
And that over-the-air update system must be secure as well, because that's another threat vector. Somebody can over-the-air update something that you didn't want. So there's a lot of things to think about.
Maybe from, I know this area is emerging, and it's emerging rapidly, but from a legislation standpoint or even a standardization standpoint, if you're thinking about consumer and industrial products, enterprise devices, these things are all emerging globally, right? So yeah. What's the first step, or what do companies need to do to proactively get engaged in this initiative and make sure that their products are safer?
I think it's hard for manufacturers, because historically this has all been left to the manufacturer. And there's obviously an increasing complexity and choice of technologies. And so it's hard for manufacturers to be able to necessarily keep up with ongoing legislation. And you're starting to see legislation in the United States, in Europe, in Asia, around what as a manufacturer you must do in the smart consumer or industrial IoT space. And that includes being able to make your software updatable through the product lifetime. Because if you can't do that, you can't keep your product secure, because we all read about these exploits, and often they're exploits that could not have been thought about when the product was first designed. Maybe is in the market, in the field, in an industrial application for 10, 15 years. And so you need to be able to update all of the software on that device, not just an application, but you need to be able to update the operating system, and you also need to be able to update the secure firmware itself, the equivalent of the BIOS in the Intel world. And that's different for every ARM chip. ARM chips are used a lot in industrial IoT applications. So you need to basically have as a company, you need to have a very experienced team who understand how to do all of this, or you need to buy in that expertise.
Got it. Those are good insights. George, another question for you then. What are the challenge facing manufacturers, that are particularly unique to this aspect of it when you're dealing with Unix? And how do they address those?
It's very tough because every product in this space is different. You're talking about everything from smart consumer devices, industrial IoT, smart cameras, automotive, robotics. All of these devices run Linux, but they all require their own software to run the hardware. So historically, every manufacturer has had to build their own. They build their own operating system and they have to maintain it and they have to secure it. And that's a very complex task. And there aren't enough security experts to go around everybody. So what we feel very strongly, our vision is, how do we create a platform for all of these different devices, like Android is for mobile phones? But it's got to be a platform that can be customized by each manufacturer. And that's really what we've set out to do, is solve this huge industry problem of fragmentation by creating a horizontal platform that includes security, includes secure over-the-air updates, and enables customization by each customer. But that customization is kept separate from the core platform. So we can maintain the core platform for 10, 15 years, and our customers can maintain their own customization over that same period. So it's a huge challenge, but I think it's one that will make a profound impact on the industry.
So basically give that Linux community some of the economies of scale that the larger platforms do, and you've got proprietary.
Yes, if you think about what Android did to mobile phones, everybody built their own mobile phone from scratch. Now everybody builds mobile phones on the same platform, and as a result, you've got this huge ecosystem, the app system, right, that didn't exist before Android. The same can happen in the industrial space, but that application ecosystem is actually open source and it's based on container technologies. So you see containers becoming the app store of the industrial world.
Got it. No, fantastic insights. Thank you for sharing with us today, George.
Very good talking to you today. Thanks very much, Greg.